All right, so now there should be the streaming link.
So Brandon, you're gonna let them each, like one person from the team, share screen, show their video, and then, is that how this is supposed to work?
Yeah.
So they may or may not have their audio properly enabled.
Yeah.
So Brandon, you're gonna let them each, like one person from the team, share screen, show their video, and then, is that how this is supposed to work?
Yeah. Okay. And I will share the link with everyone. Then Joanne and Amber, I'll make you guys co-hosts.
Thanks.
Yes. Cool. Yeah, I'll make the announcement now. I guess I'll share screens now. So, all right, yeah, welcome to our top 10 judging demos. Right now, we're getting towards the end of our event, so thank you all for coming and sticking through. You guys have made a lot of really great hacks, and I've been really excited to look at them actually. But yeah, moving on to the schedule. Right now, we pushed back the demos and judging a little bit, but we're still planning on having awards and closing ceremonies at 2 p.m. Eastern Daylight Time. Just as a reminder, our judging criteria are usefulness, polish, creativity, and technical difficulty. This is what we've used for the science fair, and this is what we will use for this top 10 demos judging. So I guess let's get right to it. Regarding the logistics, once we get to your team, please share your screen. Make sure you have sharing computer audio enabled, and make sure it's optimized for video sharing. And at this point, I guess just share your demo video, and then we'll be asking any questions. So without any further ado, let's get to summary.
All right, hi everybody. We're Team Summerread. By the way, is it possible, since our video is short, if we did a quick live demo afterwards?
As long as as long as it's within 5 minutes, I want to make sure that this is as quick as possible.
All right, for sure. We'll definitely do that. All right, since you want to start us off, let me get a screen share going. Yeah. Could you enable screen sharing?
Yeah. Okay, it should be available.
Perfect. Everyone can hear it? Audio works?
I don't think I can.
Does it have audio?
No audio.
No.
Yeah, let me try it again.
Yeah, we tried.
I think it might be a setting. Yeah. Okay.
Per deck. And even if these other
That works. All right, sounds good.
at room temperature, the subthreshold swing in a MOSFET is limited to 60 millivolts per deck. And even if these other solutions are successfully implemented, the resultant device still functions based on the same physics.
Did you get that? Neither did we. As it turns out, taking notes when your professor is speeding through MOSFET at the nanoscale is incredibly difficult. Who would have thought? And we all know that no one wants to sit through the 2-hour-long lecture recording just to find out that they missed a key idea. And that's exactly why we made Summer Read, because lectures don't have to be confusing. Now you're probably wondering, what is Summer Read? Summer Read is an advanced AI-based tool that automatically generates lecture notes and key topics from transcripts and ports them into a PDF so you can study anywhere. Let's take a closer look at what Summer Read actually does. First, paste the link of the YouTube lecture into the space, or paste the lecture transcript directly into the box. Then, click the Submit button and you're done. Within seconds, your automatically generated notes are ready, and click on the key topics to get a high-level overview, or download the notes as a PDF so that you can review the lecture anywhere. So who can use Summer Read? As a student, having lecture notes to quickly summarize the key concepts and follow along when your professor is explaining a confusing concept can save you time and help you understand the concepts better. As a professor, you can automatically generate lecture outlines for your students to follow along, or even create note takers for students to fill out. How does Summer Read actually work? Let's take a closer look. Summer Read is built on a high-powered, reliable tech stack. We use the Google Cloud Platform API to host our NLP stack from Hugging Face, the Vision Intelligence API to detect when the presenter is switching to a new topic, and the Natural Language Processing API to detect key concepts from the summarized topics. We're currently working on making Summer Read even better. Future steps include faster processing, app development for mobile devices, customized note summarization options, and automated scheduling for weekly or daily lectures. Tired of taking notes and excited to try out what we've built? Drop a like on our dev post or check out summerread.tech for more. Thank you for listening.
All right, great. So that was our video. And so next, if I can exit this, we'll just give a quick, just show everyone how our thing works. So it's super easy. All you have to do is go to summerread.tech. You press the button and it'll take you to the screen where you can enter the lecture video URL. So you just copy paste it, format a little bit, and then you hit submit. Now, we've already been running this demo nonstop for the last few hours, so we'll just jump straight to the results page to show you what it looks like. So in this case, we entered the video for about COVID that you saw earlier, and it generates the screen using both the Google Cloud API as well as the natural language processing. And what's really important to note is that with our algorithm, we're able to condense all the material down to just 10% of all the text that was spoken without actually losing any relevant information. So what we do is, using our machine learning algorithms, we keep the most important main information while getting rid of unnecessary details. And if you look closely, the results actually do make a lot of sense because every major bullet point is talking about a new idea. For example, this one's talking about the origin of the virus, while the sub bullet points tell you other things that's related to and how the transmission worked. And later on, we've also got things that talk about, for example, the RNA-based tests that we use to detect coronavirus and the pluses and the minuses of it. So overall, you can see that we're able to generate very efficient and concise outlines. And it works for other videos as well. Here's just a brief description of one that we ran on a MIT computer science video. And that's our presentation, and we're open to questions.
Yeah, hey, I've got a quick question. Do you guys do anything like, do you actually put like links to the video and associate that with the text so someone could read that and then zoom into the video and watch that?
That's a great idea. It's definitely something we could implement in the future, because right now when we generate each part of the lecture outline, we do keep track of like what timestamp or like what minutes, like minute 3 to minute 5, for example, like this block of text was associated with. So we could insert some sort of URL like that in the future.
Thanks.
Good question. Another question here as well. I noticed in your earlier presentation that one of your goals for the future would be to improve performance. How long does your processing currently take, and what's that processing infrastructure look like?
Yeah, that's also a really great question. So right now, I'm hosting the model on my personal computer, just because we tried to host it on Google Cloud earlier, but the transformer models we're using are too big and there's not enough RAM on those servers. So right now it takes around 2 to 3 minutes to process an hour-long video transcript. But if we scale this onto the cloud, or if I fix my GPU so it's working properly, we could probably bring the times down.
And another thing we can do is there's actually smaller models that we were hoping to try out, but didn't have the time. So these models would be smaller in size. So the model we're currently using is about 1 gigabyte totally in size. So if we were to find a smaller one, that would make it much more efficient in terms of the runtime speed. And since the user is going to be kind of waiting on that, we want to make sure that we can minimize that. It should be sort of instantaneous.
I have a quick question. Was there any consideration given to caching here, in the sense of, it seemed like you pasted the example video and it reran the model? Perhaps some future improvements can involve speeding up that process by serving existing info. Was that considered?
You want me to take it? Yeah. All right. Yeah. So that's definitely a good idea. I guess if we were to implement something like caching, we just didn't quite have the time to do it during this hackathon. We could probably just have a database where we'd map each like video URL to like a pre-generated outline. So maybe if we're deploying this onto a site like MIT OpenCourseware, where we got the videos, we could just run this once for every video in the database, and then that would make it a lot easier for users in the future. But yeah, also definitely a good idea.
Yeah, just to add on to that, we were thinking about implementing a front-end feature where users can actually decide how long the notes they want R to be. And this really ties along with the fact if we use a smaller, like a compressed, more efficient model, then because results are like instantaneous, the users, we wouldn't need to cache because the users can set the lecture notes generated to their own preferences in terms of the amount of detail given and the amount of lecture summarized.
Cool, thanks.
I would add, if you guys would have a database to do that kind of caching or stuff like that, you could actually have users submit changes to the text and improve the results.
Yeah, absolutely. Like there's definitely, since we're using these like machine learning models, they're definitely not perfect. And sometimes, for example, sentences get cut off, maybe like right here. And these like small grammatical things, we can either improve the model or have users help us perfect the transcripts, like you said.
And if users perfect the transcripts, you could actually feed it back into the model.
Yeah, definitely. Like we definitely plan on continuing our project afterwards and trying to talk with any experts who might know more about this field on how we can create better quality transcripts for the user. Any other questions?
What was the single hardest thing for this project in the last 48 hours?
So I think we're all going to have different answers to that because we all worked on like pretty different parts and we each like struggled on our own independently. So for me, the hardest part was I worked a lot on like the backend data processing stuff where so Brandon fed me timestamps of when the lectures changed, and then I needed to group the transcript into the given timestamps for the video lecture. So like group them into like slides so that each points were relevant. And then this was like one of our main novelty methods in improving the NLP model and the NLP results. So personally, I think just getting like the times to work on like a large scale was pretty difficult, and like it was like a lot of like for loops and all of that.
Yeah, and I think kind of adding on to that, these NLP and machine learning models can be very finicky to work with, and they often even the best of the best models that we have these days are only good in certain conditions. So kind of playing around with the conditions and just getting the right one, and feeding, kind of massaging the input data, as Matthew said, to make sure that it was kind of grouped by topic or grouped by slide. That was probably the hardest part, and I think that definitely had also the biggest effect on the like kind of the coherence and the general concision of the note quality.
Yeah, and one really quick add-on, one thing that took a good bit of time is making sure that our model worked on not just one YouTube video, but on nearly every YouTube video that has a transcript. So whether it comes from a computer science class or from a biology class or from Harvard or literally wherever, we're able to process all of them the same way. And so that's something that took a lot of time, but we're very proud of it.
Cool.
All right, cool. Thank you, Summary. And we'll move on to our next one. Next, we have leftovers. Does someone from leftovers want to share the video?
Hello. Am I audible?
Yes.
Yeah. So just give me a moment. I'll share my screen. So my screen is visible, right?
Yeah.
Hello.
Yes, it is.
So leftovers. Food saved is food shared. So what we thought for this app was, we took the problem statement as to remove the world hunger, and yeah. So world hunger is a huge problem across the globe, and since many ages, this problem has been existing. So to overcome this, we thought of a solution through mobile app and to help the needy people near you to get food from hotels or people who are willing to donate nearby. So as the theme of hackathon was generally a general one, so we thought to go with food, and we took the problem to eradicate world hunger. And coming to some of the surveys which we did, some hotels by the end of the day have had enough food left to feed at least 10 to 25 people, and most of the hotels would just throw them away. And even at houses, after the parties or after a person has finished eating, there would be leftovers. So we thought, why not share this food with people who are in need of the food. Some of the use cases and user stories are, as the user of the app, you can search for free food available in your nearby area, and the users can also set the distance radius to search for available food. And if you are a user and if you have excess of food in your home, you can share it with other users of the app, and the user can choose between vegetarian and non-vegetarian food options. And we also implemented this feature to increase connections and develop new friendships, so that a person, when he uses the app and goes to get the food, he will also meet the other users of the app and can thus increase his connections. Some of the assumptions which we did were, we thought to keep we thought that every person has a smartphone, and obviously if a person has a smartphone, he would have mobile data connection. So with this data, we went forward with our app. So these are some of the screens. As you can see, the first one is the splash screen, 1, 2, the sign in screen, the sign up screen. All of these were designed using Adobe XD only. And these are some other screens. So coming to the tech stack which we used React Native for developing most of the coding parts, Firestore for database, and Visual Studio Code for editing and all. And I have my teammate here with me, Chirag.
Hey.
So, yeah, Chirag is here. So I'll just give you a demo of the app now. You can see my video, right?
We're not seeing the screen. I just see the browser.
Okay, just share. Yeah. So this is our app.
If there's audio, we can't hear it.
Oh, okay, I think there must be a problem here. Yeah, there was audio. Just give me a moment. Can you hear? Can you hear it now?
No. There's a setting in Zoom to forward your audio.
Hello.
Yeah, there's still no audio.
Okay, I'll just explain using a live demo only. So this is the app screen, and we are running the app through emulator. So if I click on next the friendship screen, this is the sign in screen, and this is the sign up part. So I'll just give it as
Sorry to interrupt. You have 30 seconds left, so speed up your presentation, please.
okay. Just give me a moment. Just sign in then. So this is the home screen. A person can search through different filters like veg and non-veg. And if he wants, he can upload a new food item also through this. I'll just give it as Maggie, and then it's veg. I click on share. It will be stored here. And if a person wants to access and go to a nearby place and get the food item, he can just click on this and he will be directed to the Google Maps. And once he inputs his location, he'll be given a route towards the place which is serving the food. And here, if a person shares the food, he will this number will be updated, and whenever he goes and collects food from another places, this number will be updated. And this is the home screen. This is the friend screen, where a person can, if he meets a new person in while getting a food, his details will be saved here. And this is the setting screen where a person can edit his username. I'll just give it as Aditya Chris, and he can set the search radius also. If I click on update, and then as you can see, my name is updated here. So this is it about our app. And if I click on logout, it will basically go to the sign in screen. So that's it about our app.
All right. Thank you for sharing. Let's move on to Q&A. For Q&A, let's also limit that to 2 minutes so that we can get moving quickly.
Okay.
Yeah.
Can I ask a little bit about why React Native?
Yeah.
Hello.
Yeah.
Yeah, actually we had planned of doing it with Flutter, and we chose React Native because the context API of React Native is pretty much easier than the ones that we have in Flutter. So because of the state management issues, we chose React Native.
I see. Thanks.
Yeah.
Question here: have you given consideration? How does someone that's using your app have, I mean, they don't necessarily have a trust relationship with the people that are providing the food. So how are they able to know what is and is not good food?
So we in the future we thought of implementing like a preferred star kind of thing. So if a person is sharing the food, he can give feedbacks also. And once a person gives the feedback, it will be visible in his profile. And depending upon the feedback and preference, uh, that's how the trusting works. So I thought we thought that it would be in a future release. So yeah.
Thank you.
All right, great. If we don't have any other questions, let's move on to our next project, Pod Concert Extension. Actually, from now, I'll just be sharing my own screen just to speed up so that we have enough time to go through everyone.
Is that all right if I do a quick live demo? Because the quality will be better if I just live demo it versus sharing a video.
I think as long as it's within the time limit, I think we really need to get moving. So try to make it as quick as possible.
Gotcha. Cool. All right. And share computer sound. Cool. So this is our project, the Pod Concert Extension, and I guess I'll first go into the motivation behind making this. So one of our team members is actually an aspiring singer, and he wants to do a virtual Twitch concert because it's definitely a bad idea to do a public one as of right now. So this extension's main purpose is to help facilitate online concert events on Twitch. So I guess I can go over some of the functionalities of this extension. We have a pop-up to begin with that will have a welcome message description. You can check, I guess, more on the logistics side of things and itinerary and other descriptive information about the event. More on the interactives for the users. We want to bring in some of the excitement that you won't really get from a virtual concert versus a live concert. So the first thing that we have is a strobe light filter, which will hopefully add some excitement. Lots of concerts have strobe lights, and basically the stream is turned dark and strobe lights appear with some mist. The second functionality we also have is a emoji generator. So to, I guess, show some excitement during the concert, the user can tap this, I guess, emoji over here, and emojis will float up. They can interact with them, maybe pop them, create little explosions, add some excitement. And on a different, I guess, emotional note, we also have hearts that they can toggle that will basically float up. You can break them. The theme of this concert is like heartbreak and love. So we had like little hearts breaking. And the last feature of this is more for the singer himself. It is basically when he sings. Yeah, so I think I played the, I think, can you guys hear the sound? Cool. Okay, so basically when the song is playing, there will basically be a bar up top here that will show the progress. You can't see it now because there's no song playing, but they can hover over the bar and they will be able to see the description of the song playing right now, as well as the time left. And I'm gonna stay silent for a sec to show you guys. So the user can basically see information on the current song playing, as well as information on the piece, maybe where they can find it and whatnot. And as you guys probably noticed, there's also a little frequency display down here with the bars jumping up and down. That is basically a JavaScript program that basically analyzes the audio element and basically displays the music visually in a pretty cool way. I think that will add some a nice quality to it. So this is basically the functionalities of the extensions that we have implemented. This is all implemented using React JavaScript. A lot of state stuff were used. Use state, use effect. Use effect was heavily used to make the animations. Basically, use effect and set timeout, re-rendering all of these maybe every 10th of a millisecond. Well, these hearts flowing up, and yeah, I guess I can open the floor to questions.
Was there consideration given to the concert owner for tracking user interaction here?
Yeah, so we definitely were trying to implement it. I was trying to work more on the back end, trying to connect a MongoDB database, as well as setting up an Express server, but we never really got the time to do it. And that would have allowed the streamer to be able to have interactions with the chat, and even the chat to have interactions with the crowd, to have interactions with each other, I guess, having like maybe a crowd of light sticks each for everybody. Yeah, and that is definitely something we will look into for the future.
Cool.
So question, who is your primary audience? Is it more for the streamer or for the recipients of the streams and participating?
Right. So this extension is mainly for the audience. So the streamer will be able to activate it, and the audience will be able to see it. They don't need to do anything. They just need to enter the stream, and they will see this extension, and then they will be able to play around with it. Maybe they don't want the strobe lights, so they can turn it off. And maybe they want to see the information. So this will all be client based.
All right, great. If there are no more questions, thank you for sharing. We'll move on to fixing bad, and I will share the video demo right now.
Is there audio on this video? Because I can't hear it.
I don't think there is.
Hey, Brandon.
Yeah.
Okay, so this is our video, and we thought that we could say something while this video is going on.
What was that?
So if you don't mind, we can talk while the video is going on, because we didn't really mean this to be at the presentation for this session.
Oh, okay. Yeah, you can. Yeah, if you want to talk a little bit about it.
Okay. So.
Hi, so we're team Fixing Bad. As you can see, our project was to make a website that will take in statements and tell you whether or not it is true. We've noticed that there is a lot of misinformation about COVID on the internet, and we wanted to build a reliable fact checker that could differentiate between facts and non-facts. So there are other fact checkers around, but they usually are rule-based, or they do it manually, or they're not very good at it. For example, we haven't included it in this demo, but if you go to Google's fact checker and ask it, is COVID a virus? It will tell you it's false. So that's why we just wanted to build a robust fact checker. For this, what we do is we take in a query through the website, we pre-process it, and then we use Google's cloud search API to go through a few trusted websites like WHO and CDC. And we get the relevant results from that through the Google search API. We pre-process those results, and then we use some deep learning models to convert all of them into semantic representations of the sentences and the query. And after that, we use a similarity score to see how similar the query is from all the results that we have. And then based on that, we say whether or not it's true or false. As you could see in the demo, we also, with the result, we also show the 3 links that we use through which we're getting this result. So yeah, for example, if you see the result for this, we have linked 3 different websites, and these websites are the ones we've sourced for this answer. But I can talk more about other things.
All right. So, okay, I've been told that we have 3 minutes left. I'll try to keep on time. All right. So the next parts are basically trying to go into a little bit detail of what we did exactly and how we did it. So the pipeline has 3 stages to it. The first stage is basically you take the query input by the user and you do some pre-processing, which is some NLP-based pre-processing. Brandon, could you stop the video? I think it's a little bit distracting. Thanks. So and then we pass this embedding through BERT, which is a modern architecture to compute good representations. Now, then we go to the trusted websites and basically we mine them for good facts. All right, so we get 2-3 trusted websites, for instance, WHO, CDC, etc. And we use the Google Cloud APIs, the Google Custom Search API to actually parse these different articles, and then we will pass all the different articles that we found out on the web, and then create an embedding which will finally be compared to the the query that we had. The main challenge that we had really, and which resounds with the NLP community, is that if you change the query by even a single word in order to negate the query, for instance, you were initially asking, is COVID a virus? And then you change it to, is COVID not a virus? Then many of the existing fact-checking tools, well, there aren't many, but even the ones that exist, they will fail because they cannot differentiate between 2 sentences which have a so slight a difference between them. And so what we did was that what we found was that using traditional NLP techniques for doing some pre-processing and then using Google to do what it does best, that is finding out good pieces of articles on the web, and then passing those things through the deep learning websites, actually improve upon the Google Search API by a large margin. So I think that was one of the major accomplishments that we had, that we could show concrete cases where we do better than the Google Search API or any existing API. And the second accomplishment obviously was that we got BERT running. We learned a lot of things on the way. Thanks for the time. I think I'm out of time.
Mm-hmm. Yeah. Do we have any questions?
Question here: how are you doing your technical comparison between the search query and your corpus with a trusted body, or you're searching through? How are you actually doing that comparison?
Right. So we found that if you take the entire corpus, so let's say you take the entire web page and pass the entire thing through BERT, and you get one representation, that is not going to be very robust. What we did was that we instead used Google to do what it does the best. As we all know, you can find the exact location of the of the phrase in the document that matters the most to the user in terms of the search query. And so we extract that particular phrase, which is called a snippet, as returned by the Google Cloud Search API. And then we compared the embedding of that particular API to our question. Now, the other aspect that I touched on was that the embeddings are very not robust to small changes. So we used the additional NLP-based pre-processing to fix those sentiments and basically normalize those sentiments across.
Yeah, I'd like to jump in there. Like Amber mentioned, we get embeddings from BERT, and then the BERT package, the BERT module we got, it also gave us cosine similarity. So we could get the cosine similarity between our query and all the possible results at like once. And then we use those, and we used a thresholding to say whether or not it's true or false. And of course, if it's like
right.
unsure.
So in this way, you can also vary the threshold of how correct you want to be. So if you set the threshold to be very high, you will almost never be wrong. Sort of, you will almost never say something is incorrect when it is not.
All right, great. Thank you so much for sharing. Next, we'll move on to CalGuard.
All right, thanks a lot.
Brendan, I think I already sent you the link. So
Yeah,
you
I
should-
can. Okay, I can just share that video then.
Yeah, for sure.
California's in flames again.
Major wildfires burn in the West.
Wildfires. Fires. It was the wildfires raging throughout the state.
Because of this, we introduced CalGuard. So today we want to become the guardians of the California. We want to introduce a machine learning based wildfire forecast system.
So first of all, we came up with the core problem that we want to solve in this project, which is how to prevent and precaution the spread of wildfires in California to minimize its effect. So our project will be building a machine learning based model on distinguishing areas of fire, burn areas, land, water, etc. based on daily weather data, and developing a web page that displays all the information to the users.
With this product in mind, we want to achieve the three following overarching goals. We want to predict the potential area that is vulnerable to wildfire and the scope of burn the wildfire could result. We also want to provide the public, that is our user, a clear picture as to where the wildfire will most likely take place. Finally, we want to help the government out to allocate their assets more efficiently in terms of regarding solving wildfire. So let's move on to data and model. So we can dissect our model in 4 basic part ways. So we need to first retrieve the data from our Google Earth engine and datasets from the weather forecast data provided by NASA. And then we're going to feed that into 2 of our regression model, and then we want to make subsequent prediction onto the maps again, so we can deploy that back to our web portal.
Right, let's look at some of our data then. This is data from our satellites. You can see these 4 examples listed here. And on the next page, you can see our weather forecast data, which is provided by NASA's Global Modeling and Assimilation Office.
Once we are able to pre-process the data, we are able to feed that data into our model. And we feed that data into A, logistic regression model, B, random tree model, and then we try to compare the predictive power of the 2. The confusion matrix here basically shows the ability or the power of each models. So why don't we first now to shift our perspective into JSON screen and see how the data performs.
And the function of this website is to correctly display our predictions in a user-friendly way. At the moment, all data is loaded. The website will try to locate us based on our IP address. If we are located in California, the website will automatically select the county we're in, for example, Los Angeles. On this California map, these red circles indicate regions that are highly possible of being burned in recent years.
And the fire icon, which denotes by the red and the yellow icon, is actually represents the past incidents of California wildfires. And they serve as a good indicator to our users.
And these are the basic functions of this website. Then we'll continue to the conclusion, which will be available at Oscar screen.
So we'll continue to talk about the novelty factor, practicality factor, and what's next should we expect.
All right, so how is our model different from other normal classification models? First, we utilize more dimensions of the data, such as precipitation and soil moisture. Our model also has better forecastability because it uses the daily weather forecast data from NASA to get forecasting ability on our model. It is also easier to access our input data into the model because it is out in the public domain.
Okay, so speaking of the practicality of our project, CalGuard is able to visualize data into user-friendly form, with features like fetching the location of the user automatically, having a dashboard that displays all the information, and focusing on an individual county. It serves as a good indicator of how public assets should be allocated effectively to prevent and mitigate the situation in case of wildlife emergency.
Next is, last but not least, is what to expect in our future CalGuard. So we can improve the model by incorporating a more sophisticated model like CNN or RNN, which is deep learning. We can also automate a model by connecting the front end with the back end more efficiently. Last but not least, we can also explore more data to improve our accuracy and ability, or we can improve our web visualization. So that's it. We thank you for your patience, and we would love to hear feedback from you.
Thank you.
Thank you.
All right. Thank you for that video. And we'll open it up to Q&A right now.
Yes.
Quick question here. Nice job with the presentation. I had a question regarding if N or multiple areas all are prone to wildfire, and one of your mission statement was to assist the government allocating resources. Can you describe a few of the heuristics you may have thought through as to how to prioritize one area over another? I mean, they all have people, all lives are important. It's just a matter of, I want to know how you were considering how to prioritize those resources.
So one way that the system forecasts, and I guess one of the key advantages is that these models predict those areas given by a specific numeric values. So everything could be represented in probability. So if we can set up a easy equation where if the confidence level of that model predicts this area is greater than all the other areas, we will able to rank this as number one. And so the government official should be able to allocate that part of that key resources into this most highly probabilistic area. But that's kind of cruel in a sense because we are dealing with probability here, but that's the general rule.
All right, great. If there are no further questions, then we'll move on to our next team, which is KidU.
Okay, thank you.
Hi, Brandon. I'm Mariana from KidU. Good job, guys, for the California fire. I like that a lot, especially from a risk management perspective. It could be very useful. Going to share the screen. And then, can you guys hear this?
HopHacks, we are KidU. KidU is a remote learning engagement tool that is specifically designed for the youngest teleworkers. A completely independent web application that provides features to complement the functionality found in most teleconferencing applications. Through the use of classroom polling, live feedback, and comprehensive reporting features, KidU provides teachers with immediate feedback. Product features include a teacher-guided questionnaire that students answer along with the lecture, a kid-friendly UI, and product design. We also have live feedback reports for the teacher so they can assess individual student achievement as well as classroom engagement and achievement levels. Why does this problem exist? Teachers have been required to lock down their virtual classrooms due to abuse by so-called Zoom bombers. Very young children aren't always capable of doing things required of the virtual learning environment, which has caused a need for significant parental intervention in the online learning environment, and this is what we are looking to fix. What languages APIs we used? We used Vue.js, Firebase, and VueFire. Time for class. Here are some UI mockups that we made. And then future plans, we'd like to make it more game-based in the future, have invite links for joining, make cohesive branding with custom created graphics, speech-to-text engine that allows students to input their answer without actually typing, a consent waiver for COPA compliance, separate designs for each grade level, as well as direct integration with teleconferencing app platforms to extend functionality for elementary school aged users. Here is some of our preliminary branding that we did, but I will be passing this off to Alex for the demo.
All right, welcome to KidU. It's time for class. Today, we'll be showing off the student and teacher dashboard, as well as the polling functionality. So to get started, let's log in as the student. As you can see, it logs in using Google, and we've logged in using our KidU email. On our database, we have this student enrolled in three classes, 5th grade math, 3rd grade reading, and 2nd grade English. Let's view each of the classes. So in 5th grade math, the teacher has already started a poll. and we can answer this by clicking these buttons. It also appears that the teacher has many questions, so we can click through all of them and it will submit them live. Now let's look at what happens when the teacher does not have any questions. Let's take a look at third grade reading. And right here, there's no quiz prompt, and it just says no quizzes, and there's no distractions. Finally, let's take a look at how the polling actually works and interacts with the database. So let's go to second grade English. So let's just pick, I don't know, this. So in our database, go to database. You can see here's our quiz. And you can also see this user, which is Kid has posted the answer smart. If I change this, let's say ugly,
We lost audio.
Yeah.
Just muted.
Hi, Kid, your team is muted.
Okay, maybe she muted, but all of them were muted.
There you go.
we have class right now, which is second grade English. Let's go here. A teacher will be presented with several options on clicking their classroom. So they can choose to pre-fill the question bank, which adds to the quiz queue, or they can do type questions on the fly, which automatically creates an active poll. For the purposes of now, well, I'll just go from the quiz queue. So I can post a quiz in our classroom, and then we can see that all our questions have updated. To see this in real time, let me log out and log in as a student. So let's see. As a student, if the teacher posts a new quiz, it gets updated live on the student side. So this is our first quiz that we saw. And if I post another quiz as a teacher, then I'll update as well. That's all we have for now. Thanks for coming to our demo.
Okay, cool. We're done now. Thank you.
All right. If you want to answer any questions, that would be great.
Yeah, let me know. I have Alex and Monsige on the call too, who did the front end work for it.
What would you say was your biggest technical challenge in putting this together?
Yeah, so I'm audible?
Yes.
Yeah, we can hear you.
Okay. So the main technical challenge was, even for that, we asked the Firestone expert or mentor that whenever a student goes and starts to answer a quiz, how do we connect that localhost session to another localhost session where the teacher would be actually monitoring it? So we were concerned about if Firestore database would be fast enough to do it, because if it isn't real time, it won't serve the purpose. But finally, we were able to do it with Cloud Functions. As it's obvious, a lot of improvements are still required. But yeah, for basics, it's fine.
Was there thought given to future work like accessibility, internationalization, stuff like, there's obviously children in many parts of the world. Can you talk a little bit more about how you plan to deliver to those children?
Yeah, so that's what I mentioned specifically towards the end as far as like what we would like to do with future work was like getting it like right now it's geared towards a very early age group as far as going from like K to like 6th grade because those are the groups that are struggling most with the adaptation to remote learning. So internationally, it would just be more or less like exploring the curriculum, like how a lot of different countries do it. I was basing this off of a very US perspective for like seeing what technologies are currently used, like Google Classroom, Zoom, WebEx, like, but it's just the school districts are all on a per basis thing. So that's why we did an app like this that could be used with a variety, like in concurrence with whatever teleconferencing application there was.
Cool.
Thank you. Passing the torch.
All right. Thank you for sharing. Next, we have Talking Piano. Does anyone from Talking Piano want to?
Hi, we're from Talking. So I think we'll first show a YouTube video and then do a demo and then take questions.
Okay.
So let me share some.
If you'd like, I could share for you.
Oh,
okay.
I got that. Okay.
We may still remember the Talking Tom app, which ignited the internet in 2010. Instead of having a catchy sound, what if we tried to mimic human voice with the sound of a piano? Of course, the idea of having a piano talking back to you might be a little creepy, but as a group of 4 outgoing musicians in quarantine, we're now finally comfortable with the idea of talking to a piano. In fact, a lot of composers get their music idea from the way nature sounds and the way people talk. For example, the French composer Messiaen was even inspired by converting the way birds sing into piano pieces. In the era of digital music today, we're now finally able to raise this analogy of sound with a much more rigorous and algorithmic level to convert human speech into a piano composition. Let's see how it's done.
Here is a sample of a human voice.
Hello, HopHacks.
Here is a piano saying the same thing. So how do we do this? We use a technique called short window fast Fourier transform to map human voice into a spectrogram. A spectrogram specifies a sound intensity and frequency or pitch and maps them as a function of time. We then extract the optimal frequency combinations into keys on a piano keyboard to produce piano music. Now let's look at the structural design of these software.
We coded the algorithm in Python. From the spectrogram, we take a time window and pick the most prominent frequencies. Then we convert these frequencies to piano keys and we assign the keys volume based on the sound intensity. We repeat this process for each time step in the audio. As an output, we generate a MIDI file, MP3, and a PDF of the sheet music, as well as a cool piano roll visualization. There were many challenges that we had to overcome, including picking a suitable time window, number of frequency bins, and conversion of intensity to key volume. One interesting example of a challenge is here, where we see many repeated notes. To make the music more playable by a human, we grouped similar repeated notes into a single long note. The amount of note grouping and number of simultaneous notes are tunable parameters that the user can interact with on our website.
Let's look at the website. We designed an elegant, modern, user-friendly web page. The user first uploads their voice, sets the parameter. Then, in real time, our system processes their voice and converts it into piano music. After the conversion, the user can access 3 different representations of their new piano voice. They can listen to the piano audio, watch an animation of the piano roll, and view the sheet music. For future development, we plan to have real-time online recording, more instruments besides piano, and more visualizations like a piano keyboard. We hope our project will inspire composers and other musicians to explore novel methods of music composition.
All right. Thank you, Talking Piano.
Right. So
would like
now
to...
I'm going to do a quick demo.
Right. Okay.
So yeah, first, I'll play an audio file that we're going to upload with sound.
I am not a robot. I am just a robot pretending to be not a robot.
So this is a little longer than the clip in our video, and it has a lot of noise. And we'll show that our algorithm can handle that. So let me go back to our website, and then, yeah, share screen. All right. So let's try browse. We'll upload a WAV file. And then let's make an easier version. So we'll set number of players to 5 and then make it easier. So this will reduce the number of notes. And then we'll upload. We can hear so the audio. And this captures the essential frequencies of the voice recording. So here's a piano roll that visualizes the audio. And we can also take a look at the music that's generated. So we can see 5 different lines for the 5 players. And the music is much simpler than what you saw in the video. Okay, so that's it for our demo. We're happy to take questions.
What is the intended use of this boy at this point?
So for future application, we're thinking if this can be used for dubbing the cartoon characters in cartoon movies, Disney movies, or using this to dub the different kind of sound that you would have in the game. For example, the cartoons use a lot of non-human voices, such as cat sound, bear sound, or even a genie sound. So our algorithm can transfer the patterns of those sound onto a human voice. So that's kind of a real world usage and application of what the prototype that we developed.
This is really unique.
Thank you.
Thank you.
All right, great. If we don't have any more questions, we'll move on to our next presentation at EDU Labs. Does someone from EDU Labs want to share
Yes,
screen?
yes, yeah.
Okay, yeah.
Is the screen visible?
Yes.
So, greetings from Team Cypher. We would like to present an idea, EduLabs. So, why EduLabs? What is the need for EduLabs? As we all know that millions of students across the world are unable to access laboratories in their universities due to COVID-19 pandemic. There is a lack of solutions which are capable of supplementing the laboratory education in this era of online education. Students feel like that the laboratory classes are just like they are being mugged up and not at all interactive. Although there are many online simulators available, but they lack in providing a lifelike experience to students. So we designed EduLabs. EduLabs helps a student learn through visualizing made possible through an immersive AR experience. EduLabs helps students to help them to learn at their own pace and at the comfort of their own homes. And all this can be made possible by installing a mobile application without need of any sort of hardware. It can be used by the students along with their existing classroom, and we hope that it will make their learning better.
Now I would like to show you a quick demo.
So, am I audible?
Yeah, screen visible? Is the video screen visible, Deepak?
No, Karthik, it's not till now.
So is it visible?
Yes, Karthik.
The video
Play
is
the
available.
video. Okay. So we are going to look the demo of our app. So as we can see that it's actually a book on which, Karthik, can you please stop the video? As you can see, it's actually a book where I have augmented the UI in the real world. The book is acting as a target image where the UI exists on it, and it's in the virtual world, but it seems that it is augmented in the real world. So taking forward to it, Karthik, play the video. There are two options on the main UI. The first one is the apparatus and the second one is the experiment. As we click on the apparatus, we have a scroll UI where you have number of options of the apparatus that can be used, that can be seen in the lab. And if we click on one of them, then we can see them in the real world. As we can go close to the video apparatus, we can have a close look to them. And as I have shown that I have also included its labeling also. And if there is a, as you had seen, Kartik, please just stop the video. As you have seen that there was a YouTube button, and the moment that we clicked the YouTube button, we were redirected to the YouTube link where in app we can access the YouTube video of the about the particular apparatus that we have clicked on. Kartik, please play the video. Yes, there also an in-app audio as well, but I guess it's not in this live session. So there, as we can see that there we have number of options. As we clicked on microscope, you can see that there's a very beautiful model of the microscope that we can see very clearly and very closely to. It gives a more immersive and interactive experience to the user. Now, going back, we also have the YouTube button for as I have told you that we have YouTube button for every of the apparatus that we have included, showing its demo and how we should use it. Now, as you can see that we have a home button. As we click on the home button, we are redirected to the first UI where we have the second button of experiment. There are a number of experiments that I have shown, as we have only included 3 experiments as we have made a prototype of the app. So when we click on the first experiment, Karthik. On clicking on the first experiment, as you can see, Karthik, please stop. As you can see that there are a number of apparatus that are being used in the experiment, and there is an objective panel where there is objective. So now we are going to drag the object, we are going to select them and perform according to the objective and going to complete the experiment. Karthik, please play the video. So now you are going to see the whole experiment. First, the first objective was to add the inorganic salt in the test tube. Our presentation is about to end. This is the last thing in our presentation. This is adding sand. The third objective was to add sulfuric acid, and we have added the sulfuric acid. And the last objective was to heat the test tube, and we have taken the test tube to the burner. And as you can see that when we take the test tube to the burner, it will show white flame. That means that the experiment has completed and the fluoride ion is present, which was our main objective. Thank you. That's all from our side.
All right, great. And we'll open the floor for questions.
Where did the team source these 3D models, and is that process scalable?
Actually, yes. The first of all, the first question that we have used the low poly models. That actually we have used the Unity 3D engine to make the augmented reality experience. So the as we know that Unity has its own asset store, and we can also get from there the low poly models. So some of the models are from there, and some of the models, simple models like test tube, we have made them on Blender. And this app is scalable, as you can see that the target image I have here, this is my book, and it acted as the target image. So actually you can give your target image also, and on a single click this app will run on your book also. And it's, thank you, that's all.
Thanks.
What is the main technical benefit from using AR versus having a traditional 3D application?
So actually the thing is that what's the real lab? Real lab is that you have the apparatus in front of you, and that's the same thing in AR. You have all the apparatus in front of you, augmented in real world, and you can interact with it. That's why we have used and we have supported it in front of 3D apps.
Thank you.
What was the most challenging part of building this?
The logic building, when we were doing the experimenting, me and Kartik were very stuck on that thing, because user are quite what can say that they can do anything, means they can do the fourth objective. Yeah, they are unpredictable. They can do the fourth objective in front of instead of first. So we were like building the logic that the user can't do the fourth objective first, he should proceed with the first. We have emptied the test tube, but we failed when we poured the sand in it. So the experiment things were kind of very cool as well as challenging to us.
Cool.
All right. Thank you, EduLabs. We'll move on to our next presentation, Searchin.
Hello, everyone. This is Samuel Nathanson from Searchin. Can you hear me?
Yeah.
Excellent. Thank you, sir. So we'll start out by giving a really brief overview of the problem that we're trying to solve with Searchin. Then we'll go into what the inspiration is for actually building Searchin. We'll introduce our product. And finally, we'll go into the technical details of how Searchin was built. So I was working on my iPhone a couple of weeks ago, and I wanted to know more about my health. I was a bit concerned. I haven't been getting enough sleep. And my doctor had recently told me about cholesterol, but I didn't know what cholesterol was. So I asked Siri, hey Siri, what's cholesterol? And Siri responded with a link to Wikipedia, and she read out the link to Wikipedia Live. So if you search cholesterol, you get Wikipedia. And basically, the definition that Siri gave me, and this is all part of the problem, is cholesterol, from the ancient Greek chole, bile, and steros, solid, followed by the chemical suffix ol for an alcohol, is an inorganic molecule. It is a sterol or modified steroid, a type of lipid. So that, I don't know what that means. I don't know what Wikipedia's advanced PhD level definition of cholesterol is, but what I do know is that when I read that and when Siri responded with that, I had no idea how to interpret that. I didn't understand it. But I realized that there's a bigger problem at hand. We have a new generation of children, of kids, who are going to be using the internet for most of their learning. Anytime a kid does a Google search, that kid has to look on the front page of Google, perhaps click a link to Wikipedia, and get bombarded with an advanced graduate definition that they can't understand. Sometimes that makes these kids feel stupid. It makes them feel incompetent. It makes them feel like they're not smart enough. And in response to that, we decided that we wanted to build a new search engine that would not only give you results based on the relevancy of the search, but also one that would give you information that's appropriate for your reading level. So that is how Searchin came about. And I'll show you our homepage real quick. This is hosted on a Google Cloud API. And we built this all in the last 36 hours. It's been an incredible wild ride. I'll admit, I do want to go to sleep, but at the same time, this is so exciting. You can type in Searchin here and search for anything, just like a normal web browser. Like let's say cholesterol. And we can bring down the reading level to a very, very easy difficulty, something that a kid or a child can understand, something that you could teach someone. And we search, and after a few moments, a results page will pop up and it will show you all of these results, but they're not just ranked by relevancy. They'll show you results and information that you can actually understand, not PhD level definitions here in Wikipedia about organic molecules and sterols, but rather, if we go to this link, we can see that cholesterol is a waxy fat-like substance that's found in all of the cells in your body. That's such an easy definition and something that a fifth grader can understand. It's a way to teach health to young children and educate the next generation with information that they can understand and not information that makes them feel stupid. Now, there are a lot of technical details with this, and I want to let Ricky, our lead cloud engineer, go into these, but I do want to point out this score. Next to each search result, we're given a score that correlates to the grade level of the article or post. We can tell that What is Cholesterol was written for fourth graders. Anyone with a fourth grade education can read this. Whereas if we go down to Wikipedia, you have to have 15th grade education, which basically means you need to be a college junior to read this without too much difficulty. So that is the problem and the inspiration behind Searchin. We want to make custom tailored knowledge accessible to anyone, and especially young children who are trying to learn their way through the world. Now I'll hand it over to Ricky, our lead cloud engineer.
Hey, thanks, Sam. Can everyone hear me?
Yeah.
Hello? Okay. Yeah, so in the interest of time, I'll just go through it pretty quick here. So yeah, we have this deployed on a App Engine instance, I guess, from Google Cloud. It was pretty easy to set up and get everything rolling here. Gave us a nice dev URL for testing before we can get our DNS actually registered and set up. The server here is running on Flask. We get a search in from the user, and we take that search. We use Google's search API to get a list of results, and we keep in mind the order those come back. We then send those over and do some web scraping to get the content on these pages, and take those using Beautiful Soup and a natural language processing library and get some readability scores. We then take those readability scores and the relevancy we had originally and make a weighted average of those two, and then display these back to the user. So it shows relevant searches that are also on the reading level without showing things that are at the reading level or at the readability that's not relevant.
All right. Thank you so much to Searchin. If you want to open the floor to questions.
Sounds good to me. Sam?
I was muted. Yeah, absolutely. If anyone has any questions, please feel more than welcome to ask them about the inspiration, the motivation, the technical design, literally anything.
Hello? Am I audible? So I had a basic question, like you told that you are deciding on which grade the information is suitable to. So how do you exactly understand? Because education is taught on a different level on different parts of the world?
It's a very, very wise question. And with 36 hours to finish a working product demo, we couldn't go into how to show people results in different languages, but that's definitely in scope for the future. Education is not measured in just one language. We just need to find a way to measure grade level and reading level across cultures. And if that does exist, it's easy, but if it doesn't, we can research it.
Yeah, but I asked because a fourth grade student might be differently educated on different levels across various countries. So how do you manage it? Is it like some country based or something?
Not currently, but we can make it country based in the future.
Yeah, thank you.
Thank you. Any other questions?
So I think the technical implication is, how are you calculating your difficulty, your complexity score there?
Ricky, you want to take that?
Sure. We're using the TextStat library, and we're actually getting a composite score of a bunch of different formulas and I guess algorithms here. The main one that we saw before was the Flesch reading ease formula. Most of these formulas incorporate something along the lines of the number of sentences, the number of syllables, number of words, and some include like a difficult word list and if things fall outside of that. And most of these are just some formula that combine these to get a number out.
Thank you.
All right, great. Well, that's all the time we have for Q&A. And we'll move on to our last submission, which is daily. If you'd like to share your screen.
So Mark's going to share his screen for this one.
Alrighty, hey guys.
How's it going? So we are daily. I'll give a brief introduction into sort of how we came upon this idea. Essentially, with the onset of COVID, a lot of course materials, important course information, deadlines, due dates, quizzes, tests, etc., have all been moved online. However, the consequence of this is that many different teachers use a variety of different sites, and as a result, students have to bear the brunt of having to manage, 5 to 10 platforms that they have to check every single day to know what they have to do that week or that day. And as a result, students become quickly disorganized. I know I personally have missed a lot of important deadlines in the past 2 semesters of online learning, just because I haven't been able to stay on top of all these various platforms. I mean, I use Piazza, Blackboard, Gradescope, Outlook, GroupMe, Teams, Sapling, and more, just to name a few off the top of my head. So what we decided to do was make Daily, which is an aggregated calendar that scrapes all these various educational softwares and puts all that information about due dates in a one convenient location. So it's a one-stop hub. I'm gonna let Mark start on the technical demo, and he can sort of walk you through how our program works.
Yeah, so this is one facet of the calendar here. We have the month view, and then we also have the week view. So if we refresh the calendar here, we're going to start picking stuff up from the REST API that we have working on the back end. And pretty much what happens, it'll scrape. Currently, we scrape Blackboard and Gradescope, and as you can see here, we have right now we have Connor's Blackboard and I think David's Gradescope, and we just have them kind of collected on the same calendar here. And yeah, you can pretty much see that it collected information from Blackboard and Gradescope pretty well. You can press on each of these tabs for further information. You can also see that it tracks the current week, so you can see what's due today and what's due later on. And this is taken directly from Blackboard and Gradescope, so you get the exact like assignment names, assignment due dates, and all of that stuff. One of the features that we have is that we wanted to connect students with their classes and assignments as well as fellow students. And we know that GroupMe is a great method of doing that. So there's a lot of study groups on GroupMe and that kind of thing. So we decided one of the great apps that we should probably consolidate onto this platform would be GroupMe. So we use an OAuth authentication here. It's in the cache right now since we did this for a couple other presentations, but pretty much it would ask us to log in with our GroupMe credentials. And then after that, it would pull up all of our things on GroupMe. And this is a live feed, so we can press on GroupMe and we can see all the chats that we have here.
Brandon, why don't you send him a message and then we can refresh the page and
Sure thing.
you'll see the actual left-hand side
Message
update
sent.
to show the most recent message.
There it is.
And there he goes. And on top of that, I just actually added a task to my own Blackboard calendar, and you'll notice that when he refreshes the calendar, it'll actually pop up in that, it should be on Monday the 14th. Yeah, there we go. It says Blue Jay Hacks, 12:30 p.m. So as you can see, it definitely represents and can scrape in real time and take this data and repopulate it throughout the calendar.
Yeah, and one of our favorite things about it is that it gives us two great views. We get the one-stop shop right here, and then we also get the overall view of the month. And one of the things that we really wanted to emphasize was just essentially connecting as many relevant platforms as possible. We know Gradescope and Blackboard are really common at JHU. We also connected SIS for class verification, or not verification, for class grouping. So essentially what we were going to do is check, we had a scraper that would go through SIS and kind of match up classes with assignments. And we were going to have a feature for that too. We had it almost implemented, but we ran out of time. But essentially, we were going to color code all of these by class. And that's something we plan on doing in the future.
It's all powered in the back end. I mean, this entire project is really just HTML, CSS, and JavaScript. We're running Node Express for the back end. We've implemented a full REST API, so the front end and the back end are completely separate. I mean, you could throw this onto whatever, it's ready to be deployed today. The biggest thing is really just that the client has this view, and the biggest issue we had was really just kind of scraping the data from Blackboard, from Gradescope. And it's a bit different because we ended up using Puppeteer, which is a headless Chromium engine. And I'll just go ahead and wrap up with this final statement. But it's a lot different than something like Beautiful Soup, which is normally just an HTML parser where you're having to send requests back and forth. That doesn't necessarily work with platforms like Gradescope or Blackboard because they tend to be locked down and almost intentionally hard to query information out of. We tried asking the Hopkins IT team if we could get access to the Blackboard API call system, but that just wasn't happening. It's locked down too tight. So using Puppeteer, we were really able to basically essentially emulate what a user does when they log in, meaning that we can actually pull down these events just as a student sees them. I guess we can go ahead and move on to questions now, right, guys?
Yep. Yeah, sounds good.
All right. If anyone has any questions, we'll allow 2 minutes for that.
Sorry if I missed this part. How do you retain credentials? So a user has to log in, right?
Right. So right now, daily currently, because we didn't have time to implement a full authentication system, we do use OAuth for GroupMe. We were in the process of getting OAuth for Slack. But as far as Blackboard and Gradescope, currently, we're just storing private credentials on our local machines. That's completely ignored in the Git repo. That's not going anywhere. That's just staying on our own local machine. And then we're making sure that if this were to be in production, that we would be transmitting those over HTTPS, making sure that we're following SSL, TLS, and ensuring that we're actually transferring these credentials properly. Ideally, we would want to tokenize all this information if we actually had implemented this, but right now we're just plain text, local machine, so it's not going out anywhere. It's just staying with us.
Cool, thanks.
So, question on the technical side. I mean, since you're aggregating information into a calendar view here, what do you see? How are you synchronizing? How, if you have an event that is deleted from Blackboard, how are you handling that?
So the idea for that was this refresh function we have currently is manually triggered. You have to actually click on that little icon in the top right. However, we were thinking of essentially having it refresh automatically every set interval of time. And in doing so, it would clear the calendar. And the way we scrape, we can actually clear the calendar and get all past events and future events that we may have deleted in the process. As well as capturing new events that were added and removing events that were deleted from the Blackboard calendar.
The big takeaway from this is really just that, consolidating all this information into one place is just going to make it a lot easier for college students to kind of stay on top of their game and know when their assignments are due and stuff like that. And it solves a problem that we've faced with the online modality pretty frequently.
All right, great. So that's all the time we have for questions. And right now we'll be finishing up the judging for the top 10 demos. I know that we went over by a decent amount. And so we'll be pushing back closing ceremonies. Please keep your eyes out for that. We'll make an announcements in the announcements channel. But yeah, thank you so much for the demos and we wish you good luck.
Thank you.
Thank you. Thank you.
Thank you.